All right, so on to the next one. This one's going to be a little tricky because we have lots of definitions to get through first. And it's a big section. Okay, so we're going to be evaluating expressions. So first, let's talk about the differences between some things. So first definition is a variable. So a variable is a symbol. So it's a symbol for an unknown number. An example would be like X or Y or any letter. So we used variables in the last section. And then a coefficient is a number used to multiply a variable. So if you see something like 3x, 3 is your coefficient. Or if it's like negative 7y, negative 7 is your coefficient. And then a term. A term is a number, a variable, or the product of both, or the product of numbers and variables. So terms are separated by addition or subtraction. So like if I see something like 3x minus 5, 3x is a term and so is 5. So they're both terms because they're separated by that subtraction sign. All right, like terms are terms that are exactly alike, right? So they're exactly alike. So what we mean by that is the same variable. So they have the same variable or they're constants, but it's the same variable raised to the same power. Okay, so coefficients can be different as long as the variables are the same. So the coefficients can be different, and constants are also like terms. Constants or numbers are like terms. Constants are also like terms. All right, so we want to know, in example 1, what are the terms in the following expression? So remember, terms are separated by plus or minus. Okay, so this is separated by a plus. So is this, and this, and this, and this. So in this case, all of them are terms. We want to know, in example 2, which ones are like terms. So which ones have the same variables? So I see an x here and an x here. And then I see a y here and a y here. And then constants or numbers alone are also like terms. So negative 4x and negative x, 2y and y, and then 8 doesn't have any friends. Okay. In example 3, what's our coefficient? Coefficients are the numbers in front of the variables. So we have variable here, and there's a number there, and a number there, and a number there. If you just see a number, if you just see a variable, there's an implied 1 in front of it. So our coefficients are -4, -1, 2, and then 1. And then last question, what are the constants? So constants are just numbers. So numbers with nothing happening to them. So in this case, it's just 8. 8 is our only constant. All right. Okay, so now that we have the basic steps down, now we're going to talk about evaluating exponents. So our steps are that we're going to plug in value anywhere you see that variable. This will make sense once we look at the problem. And then we simplify. Remember, we simplify using PEMDAS and then left to right. Okay, so looking at this first example, I have that x is equal to -2. So anywhere in here that I see x, I'm really going to replace it with a -2. So this is really 3 times -2 plus 4. And with PEMDAS, we do multiplication, then addition. So we would do 3 times -2 first, which is going to give us -6. Bring down that plus 4. And then -6 plus 4 is -2. So then that's our answer, because we're evaluating that expression for what it is. Okay, so I'm going to do one more with you. So for this one, x is equal to 2. So anywhere I see x, I'm going to plug in a 2. So this is really 2. This is really 2 times 2 plus 5 times 2 minus 12. So again, I have to multiply. 2 times 2 is 4. 5 times 2 is 10. Bring your plus sign down. And then bring down the minus 12. And now we go left to right. So we do 4 plus 10 is 14. Bring down the minus 12. 14 minus 12 is 2. And that's our answer. So I want you to pause and try example 6 on your own. So pause this and try example 6 for me. All right, so hopefully you knew we saw a y. So we plug in a +3 for y. So that's how I get right here and here. And then we have to evaluate that. So -5 times 3 is -15. 4 times 3 is 12. Bring down that -7. I think where if you went wrong, it was probably here, getting this -22. They're both negative after you do keep, change. Okay. So that means you really add them up. That's how we get -22. Plus 12, that's how we get -10. All right, so now we're going to move on to combining like terms, which would have helped make 5 and 6 a little simpler. All right, so we're going to start by going over the steps. So this first one is first 2 are like stepping stones until you get more comfortable with it. So let's just write those down. So we use different shapes or colors to identify the like terms. So what I mean by that is anything with a like term, we're going to use either the same colors, which is what I'll probably do, or if you want to use the same shapes, that works too. Then we're going to rewrite the expression and put the like terms together. So after a while, step 3 is really where you're going to start. So once we put the like terms together, now we're going to combine them. Combine like terms. And what I mean by that is do the operations between them. And then what we need to remember is for variables, you combine just the exponent, just the coefficients. All right, so I know it doesn't really make sense, but let's look at this first example. So we want to identify things with like terms. So I would identify everything with an X. So I'm going to put everything with an X in a box. And I also put their operation with it. And then do I have any other variables, any Y's or anything? Do I have constants? Remember, constants are like terms. So I'm going to put them in a circle. So now that I've identified all of my terms as like terms with each other, now I rewrite those. So I rewrite 4x plus 8x. And I got this plus because it's right there. I'm going to write plus 3 plus 7. So those are also my like terms. So that was step 2. Now we're going to combine them. What is 4x plus 8x? And remember I said for my variables, you combined your coefficients. So it's really 8 plus 4, which is 12. And then our x comes along for the ride. And then we do 3 plus 7, which is 10. And that's our answer then. All right, so we're going to do one more together. So we're going to do one more. So again, we want to identify our like terms. So anything within a variable or with the same variable, we'll start by putting it in a box. Remember to keep its operation. Constants, we put in circles. So now that we've identified them all, we rewrite. So 3x minus 5x plus 4 plus 10. And now we use our coefficients. 3 minus 5 is negative 2. Our x comes along. 4 plus 10 is 14. And that's our answer. I want you to pause and try example 8 for me. Pause and try example 8. All right, so hopefully you got 11w minus 3. If you didn't, check my work, but I'm going to move on to example number 9. The only difference with 9 and 10 is that just kidding. I want you to try example 9 now. So if you were good with example 8, and even if you weren't, I want you to try example 9. The only difference is that it's a little longer. So let's try that now. So pause and try that. All right, so if you did try that, just be really careful with your signs. So what I think might help is taking it one step at a time. So I simplified these, and then I brought that 4 down. I simplified these, and then brought the 3 down. And then I simplified. And then I noticed that this was a plus 0, so then I just wrote the answer. Okay, so just be careful with your signs and your addition. So we're going to keep on going to example 10. What do you notice that's a little different about example 10? I notice that there's 2 variables. So if there's 2 different variables, like an x and a y, those are not like terms. They have to be the same variable. So now we have 3 different categories here. We have our x's. We have our x's. We have our y's. And we have our constants, which I'm going to use a triangle for. Okay, so we're going to be combining those 3 separate things. So we do 16x minus 8x minus 3x minus 3y plus 2y plus 4 minus 8. Okay? 16 minus 8x is 8x. Bring down our minus 3x. Negative 3 plus 2y is negative y. 4 minus 8 is negative 4. So we're going to keep on combining our x's. This is 5x. Our y we already simplified, and our 4 we already simplified. So then this is our answer. Okay, so you just got to take it one step at a time and just be careful with your signs. All right.